Hello everyone. Today we're going to be discussing how to best establish and perform a design of experiments. In our case, we're going to be focusing on how to create an ideal beer head. Now before we move along, we'll need to kind of first establish or run through the general framework for a proper design of experiments. As you can see, there are quite a few different steps that are actually going to come into play here. The first of which is just going to be the recognition or statement of a problem, of course, that we hope that we can solve or that we'll have some adequate results to really measure. The next is going to be the choice of our different factors and levels. These are just going to be the variables that will be adjusted, hopefully determining some part of influence in terms of how we create this beer head. We'll also need to select a response variable. In our case, this has already been stated. This is just going to be the beer head itself. We'll also need to go through and kind of structure the proper design, of course, perform the experiments. Depending on our experiment results, we'll of course need to analyze that information, hopefully giving us some proper recommendations and conclusions based on what we found. So the first step, again, is just going to be that general recognition of a problem. So in our case, again, we're going to be wanting to test and evaluate the creation of a beer's head. We're going to be doing this by actually weighing our null hypothesis, basically just the variability of each one of our factors and their interactions together. Next, we're going to go through and design these different factors and levels. In this case, we're going to have quite a few different prospects that we could go through and actually measure here. These are going to be the different options that we could adjust and that we could change as we move along throughout the experiment. In our case, this is far too many factors to, of course, evaluate at the same time, so we need to trim this list up a little bit. As we can see from the table here, we've gone through and established three different factors. We've got the type of the beer, which is either going to be a light beer, which is Bud Light, or a darker Yuengling lager. We're also going to have the establishment of low and high settings for a pour angle. We're going to have a 90-degree pour angle and a 45-degree pour angle. The last factor is going to be the cleanliness of our cup. So as we go through and actually perform the experiment, it's going to be done either with a dirty glass, which would just be remaining residue from previous uses with beer still inside the cup. Of course, it's going to be empty, but again, we're going to have some lingering residue. Or of course, it will be just a clean, dry cup. The next step, again, is just going to be the establishment of what we're going to measure, which is that response variable. Now we'll just take a kind of a sidetrack here for just a moment and kind of define how we're going to be measuring this and of course what we're going to be measuring. So we are going to be measuring the beer head, which is just, as you can see, the layer of beer that we're going to have collected that's been created at the top of the glass as we go through and pour and after we finished our pour. So as you can see right there, we're going to be doing this from the measurement in inches of our observation or of our beer pour. Next, we're going to have that establishment of the experimental design. In order to go through and kind of really just define how many steps and how many trials we actually need to go through for our observations. Due to our factorial combinations, we're just going to choose a 2 to the 3, which is going to be 8 total combinations. Again, those are going to be combinations of the Yuengling or the Bud Light, the 90 or 45-degree glass angle, and is the cup going to be clean or dirty. We're going to replicate each combination 9 times, giving us a total of 72 observations. Now for the performance of the experiment, we're actually going to take a quick detour into a video that will kind of walk through how we can best recreate and how we can best perform our experiment.
Hey there! I didn't know we were rolling. So what we're going to do to get started with our experiment today is design of experiments. We're going to be measuring the beer head height. So really how we're going to be doing this. We're going to start out with our pint glass. For all of those of you following along at home, we want to make sure that we're really going to be using the same set, at least, of pint glasses. We want to make sure that there's really as little variation as possible as we go through with this experiment. So as you can see, we've basically got this glass propped up. In this case, we're going to be using a couple of textbooks. Who needs them when you're doing design of experiments on alcohol anyway? We're also going to be using just a nice right edge ruler. to measure the beer height. So as you can see, we can just prop that bad boy right up against the glass. We've kind of got this nice Auburn logo turned out of the way a little bit so that we can really get a full effect for the beer head. Now the best part's really going to come into play here. We get to just crack open our brew. So we're going to go ahead and do that. Now when we're performing the experiment, we've really got two different options. We're going to go through at a 90-degree angle, which is where we will really just be dropping the beer straight in there. It's going to be going, as you can see, at 90 degrees. The other option will be actually tilting at a 45-degree angle, roughly, and we're going to be pouring it up against the wall of the cup so that we can really limit the beer head as much as possible. So to go through and just start with that, let's just begin with the 90-degree head height. This is going to be the most important because really what we're going to want to make sure that we do is actually capture the picture of the head height whenever that beer head starts to actually rise from the bottom. So we're not so much worried about the beer head at the top. Certainly we don't want it to overflow, but it's really going to reach a pretty peak value, and then that beer head is going to no longer be coming closer to the bottom of the glass, but it's actually going to start rising up. So let's just go ahead and begin our experiment here. So again, at the 90-degree angle, we're just going to tilt that bad boy in. We'll see that beer foam just really kind of rising up. We're rising up, rising up. So we're going to continue that along the way. And then we're going to start to get to this optimal value, and you can see that that beer head is actually beginning to rise. So at any kind of standardized point when you start to see that, once you've hit the top of the glass, we're going to want to make sure that we record that image so that we can put it in the archive and basically measure that beer head. Welcome back. So we've enjoyed a nice beverage if you're 21, and we're going to begin this again. So we're going to start again, our same materials. We're going to be using a clean glass for this experiment, so make sure that you wash it out well. I've dried it. If you remember correctly, that was actually one of our factors. So of course, if it was going to be dirty, leave it dirty. So now we're going to begin with the 45-degree pour. So we're going to go ahead once again and just pop this open, and we'll just tilt the glass and begin our pour. So now you'll see that of course this is going to come in, and you'll notice right off the bat it's going to be a much more limited head on this beer. So we're going to pour almost to completion here, where we're going to really run the beer dry. So we're just finish up the pour, and then we can prop it up, and we would take a picture at this point. So we could just go ahead and take the picture, and then of course after we've done so, it's been recorded, we can just go ahead and enjoy our beverage.
Alright, welcome back everyone. I hope you enjoyed that short little video. I know we did. And now once you're done with your data sampling and you actually have all of your recorded data, and you know you're either out of beer or just can't quite see what numbers on that ruler anymore, it's time to get down to brass tacks and start analyzing the data you've collected. And so moving on here, what we're going to do is we're actually going to use Minitab in order to analyze our data that we've collected. And what you can see here is kind of a spreadsheet that we have created in order to keep track of all of our observations. And this is exactly the way you're going to put it in Minitab. You can put everything here except for the head height in, you know, before you actually carry out the experiment and before you do anything to kind of pre-prepare yourself here. And what you're going to see is the beer, the glass angle, and the cleanliness here are our input factors, and the response variable of the head height is what you're going to record as you go through the experiment. You're going to represent it exactly like this in Minitab, and then you're going to move on to define your factorial design. And to do that, you're going to go to the Stat ribbon at the top, and then choose DOE, and then Factorial, and choose to define your custom factorial design. And once you do that, you will see a window such as this, and you will select either the 2-level factorial here, and these are just representative factors of our experiment here. They are not actually the ones we use. They are just, you know, a general sample of what you may see. And if you select the low-high option, you will actually be able to define your low and high values of your experimental factors here, which would be the cleanliness, yes or no, the Yuengling or Bud Light, and etc., as we used here. And then once you've defined your experiment, you can actually move on to analyzing your factorial design and your data. And so to do that, you're going to go back up to Stat and then to DOE and choose Factorial. But this time you're going to go to Analyze Factorial Design, and you should have that available now. And when you click on that, you'll see some windows such as these. The one you'll see in the top right will be the one where you select your responses, and that's going to be your head height in this case. And then if you would select the terms option there, you'll see a window such as the one on the bottom right, and you will be able to select the terms that you would like to analyze. These will be the main effects and the interactions of these as well. As you can see, all main effects and two-way interactions will be displayed, but Minitab will remove any three-way or higher order interactions, and you have the option to select those yourself. You can also select the graphs option on the initial window and choose to create some specified graphs. Any graphs that you desire to create with your report can come out here, and you'll see that in the lower left and some of the options you can choose. And then once you have done that, we'll move on, and this is just a sample of the output that we have after running our design of experiments calculations. And this is an ANOVA table that you'll see, and pretty much the only significant result we received from this is the pore angle was a significant factor here for the beer head height. And you can tell that by checking out the p-value there. It's approximately 0. We had a significance level of 5%, which is anything less than 0.05 is going to be significant. And as you can see, the pore angle is the only thing that was in this case. A little bit of further analysis are some of the graphs that you can generate through that DOE factorial design and analyzation. So what you will see here is in the bottom left, the interaction of the two, of any two factors that you'll see here. And in the middle, you'll see the main effects plot, which for the clean and dirty and the beer type are quite obviously pretty much non-existent, but the pore angle you can see between the low and high value, there's a pretty significant variation in the head height. The last thing you'll see here is the cube plot that we have in the bottom right, and that just shows the means of all three factor combinations. And again, the most significant thing you'll notice here is the top of the square is at the lower level of our pore angle, which is going to be the 45 degrees, and the bottom values on the square are going to be the 90-degree pore angle. And as you can see, there is a significant difference between each one of those pairs of points that match up there that lets you know that as the pore angle changes, that head height of the beer does as well. And now moving on to our last part of the framework is the conclusions and recommendations. We have concluded, as I mentioned, that the pore angle is the only significant factor that does affect the head height of the beer. Whichever factors you choose as your factors for your experiment will vary as to what your conclusions and results come out as. Our recommendations are to pour at a 45-degree angle to minimize that head height, and then to go ahead and keep your glass clean since it's not important, and go ahead and use whichever beer type you prefer. But depending on the factors you choose, as I mentioned, will determine your results, and you can come up with any recommendations that you have on your own.